Okay, good afternoon, everyone. Again, our second presentation is based on towards grid techniques for sensory sensors and ambiguous computing and engineering solution in Jamaica. And so this is presented by this engineer, Mr. Christopher Udia. He's a senior lecturer in the School of Computing and Information Technology, faculty of the Engineering and Computing University of Technology, Jamaica. He holds a bachelor's degree in electrical and electronic engineering. As well, he holds a master's degree in digital and technological from the University of the West Indies. I would like to present to you all Mr. Udia.
Good afternoon. She already introduced me, I would like to take an apology because some who said they don't understand me very well. I have to speak very slowly because all of us are not here from Jamaica. So the topic is towards green techniques for sensors and ubiquitous computing and engineering solution in Jamaica. This area will let us make the country look like other countries. We are looking at what sensors can be able to bring in. If we go to sensor technology and ubiquitous computing, we're going to have a number of solutions in the country because the other places, there are crimes. Jamaica is not only country we have crime, but the problem is if there is any crime, are we able to detect them? Are we able to arrest them? In US, crimes are there, but maybe a few days they'll be arrested. Why? Because of these technologies. So if we go in, we'll be able to see how sensors will be able to help us. Even in Jamaica is one of the countries that is exposed to hazard like hurricane. Sensors will also help us to detect. It might not be solution, but it's going to help us to detect so that we can be able to prepare. We cannot be relying on other countries to be giving us information. Okay, next slide. I'll say, making a built environment smart. What we are talking about, making environment smart. If environments are smart towards sensors, it means we are going to be very specific, measurable, available, relevant, and work within time. A wireless sensor network, especially distribution of autonomous sensors to monitor physical and environmental conditions such as temperatures, sound, pressure, bridges, landslide, hurricane, global warming, tornadoes, earthquake. No. Okay. Next. Sensor network and its environmental impact. Like I earlier said, making built environment smart to help us in earthquake, global warming, landslides, tornadoes, tsunamis, water quality monitoring, robotic sensing. These days we have robotic restaurants, robotics monitoring, a lot of things, robots playing footballs. And then this technology has some problems which we are going to see as we go on. The main aim of this work, we are currently working in the lab now, is to develop a protocol. This protocol is called Automatic Congestion Detection and Control Protocol. By the time we have so many sensors everywhere, CCTV, monitoring, we are getting a lot of data. And if data are obtained, then they are and going to one node, they will be delayed. Every packet going through a network has a packet lifetime. And when there's a delay, once there's a congestion, there'll be a delay. And once there's a delay, the lifetime will go. Then that packet will die. Then we cannot get information from that sensor. Now we are trying to develop this particular protocol. Maybe during simulation we can see how far we have gone. Next slide. See the block diagrams. You can see earthquake, can see tornadoes, can see hurricane. Even in some countries, like we're talking about water pollution, in some countries, probably in Nigeria, South Africa, and oil developed countries, are what they call hydrophones. When you hear about hydrophones, some people say, why? Those sensors going into the sea How do we get oil on the sea? Nobody will go inside and die. Will blow dynamite, and then the sensor will send signal to dictate what is inside the sea. In that case, call it hydrophones. Now you see geophones. Geophones also mean the signal will send through the earth. We can't be able to do, initially when we are doing oil well, have to drag, make a tunnel. How many time, how long will it take, how many weeks will it take you to drill a tunnel? Now we use a geophone, and geophone we blow a dynamite and it sends signal, and you'll be able to know the texture of the ground and know what is beneath, to know the type of quality of oil you have. These are things we can obtain from the sensors. Next slide. Smart homes. Some people are going to smart homes. You have fridges, you have TVs, all are interconnected. You can be outside your house and be monitoring what is happening in your home. Smart campus, some universities are there. We're working on smart campus to make you take one of the first smart campus in the country. If we have smart campus, once you're at the gate, you know what is happening, all part of the school. You know all the departments, there'll be smart board for you to know what is happening. Now, smart boards, smart cities, like I know the government is working on smart city in New Kingston. Why, if you are driving to New Kingston and there's traffic, maybe you're somewhere in downtown, you will be told, so they can take another diversion. If we have got those smart, then CCTVs are things that will help us, cameras, sensors, and PON. Some people say, what is PON family? These are the new current networks. We call it passive optical network. Some of DigiCert, I'm not going into this passive, we have active, we have gigabit optical network that uses sensor network. These are the new technologies. Next. Okay, earthquake, we already seen, I don't want to go detail into definition, but earthquake is a natural disaster that comes from the shift on earth crust. Nobody will know when it is coming, but sensor can help us to dictate. And we can say earthquake cannot be predicted, but with aid of a sensor we have been placed that if it is placed beneath the earth, we can be able to know when it is coming and be able to prepare ourselves. Next. Under the earthquake, we have many types of waves. We have body wave, primary wave, secondary wave, surface waves. These are the waves that come from the earthquakes, and this wave determines the category. We have love wave, red light waves. Wireless sensor network can monitor the earth crust and dictate the slightest change in seismic activities. This can be evaluated over time by seismologists. These are the people who will be telling us, who giving us weather, telling us what is happening on the earth. Next. Global warming. Global warming has become a major concern to many countries. Commercial and industrial factories produce a lot of carbon dioxide and other greenhouse gases that contribute to warming of the atmosphere that is also impacting heavily on the water. Sensor network also help us to monitor the global warming. Next. Landslide. Landslide is also known as landslip. It includes a wide range of ground movements such as slopes go up. Sorry, I have not told you this is done on praise. We are trying to work on new technology, so we're supposed to have a backbone of internet. It's not on PowerPoint, so this way these things are coming up. I have to zip the file because of this presentation. It's praise. Some of us might not be used to it here. Close. Use end process here. Minimize, okay. Okay, minimize, okay. Slopes, rockfall, and shadow. Next. We can see effect of landslide. With adequate sensor, this we'll be able to know. Next. Water quality monitoring. Sensor could also help us to monitor quality of water. Right now, Jamaica is experiencing heavy water loss. We can be able to, not everywhere is getting enough of water now. So this will also help us to monitor our dams and be able to control it. Next. Firebox. Fire is something that nobody can control. Fire coming, alarms here and there, sensor networks can also help. Next. Tsunami, like happening in China, India. Tsunami is caused as a result of water waves, which can be caused by displacement of large volume of body of water, generally an ocean or large lake, based on principles of flotation and displacement. Next. We see tsunami, ocean rise covering the entire country happens in Japan, and sensor technologies will help us. Next. See, level of environmental impact caused by earthquake. We know what happened to our neighboring country here there's one country in Caribbean that suffer a lot of earthquake. Haiti. Next. See, like I said earlier, these where roads will be monitored, CCTV cameras, sensor monitoring roadways. Somebody cannot go to machine and you start your card and they take your money. If these things are underplaced, like in New Kingston and big cities, nobody will tell armed robbers or criminals not to do, but definitely will be arrested because these things are there to help us, even the ATM machines. Next. We can see sensor network application in reading data from the nodes. We see the nodes, how they are scattered. We see the gateway. The gateway is the big one that connects to the computer. So somebody can stay on a device watching and be able to monitor what is happening to the entire country. Next. We see the block diagram here. You can see receiver, you can see where the sensor is monitoring. You can see other sensors there, getting data, and all data will go through the ADC, analog to digital converter, and this will send it to comparator, and comparator will compare the signal, balance it, and send to processor, and move to another level of comparator, and then it is displayed in the computer. These are what the block diagram of the application. Next. Now, these are bundles, ad hoc wireless sensor network monitoring the whole, let's say, the entire city. Can see sensor devices, and this where it has a great disadvantage. The only advantage is that when there are so many, there will be congestion. Like I said earlier, we are going to meet that. You can see these are getting data all over the entire country, and it will help us a lot. Though the implementation might be costly, earlier starting might be a lot of cost. Next. Okay, measurement of degrees of earthquake also can help us. There's this instrument called Mercalli intensity scale. It's a seismic scale used for measuring the intensity of an earthquake. It measures the effect of earthquake and distinct from the moment magnitude usually reported for an earthquake, sometimes misreported as Richter magnitude, which is measure of energy release. The intensity of an earthquake is not totally determined by its magnitude. Next. Okay, we can see the levels of magnitude. Can see from 8.0, the one that hit Haiti is about 9, which is very big as the width big. That's why the intensity is, and these sensor devices, sensor technologies, masters can be able to help us. Next. Now, limitations. This ongoing work, we're still doing work in the lab here. Wireless sensor network suffers some limitation due to congestion of data at each node. Like I showed the ad hoc diagram. If you go to the extent, too many of them, if you are capturing too many sensors, capturing data, sending to one gateway, there are bound to be a congestion. And once there's a congestion, data is delayed. And once there's a delay, every packet, everything going through the network has what they call lifetime, life of the packet. And once the life packet expires, then it will be a loss. So delay due to congestion and packet loss, then the packet start escaping. Among all sensor network, if it is in area where there are criminals, some technical one can send wrong data. It can be sending wrong data. So there's another limitations. Next. Now, because of this limitation, what do? Now, automatic congestion detection and control protocol. This is the major work we are doing. Maybe we'll go to the simulation part and see how it runs. Otherwise, you can take effective bandwidth utilization. When we talk about bandwidth, we send it through the network and be able to know the limit bandwidth can go. And by that effective bandwidth, we go into multiplexing. Multiplexing is what many of us must have done in the school, in networking and ICT. That's when we are sending multiple signals through one line. If we are sending 8 lines of data from Jamaica to Australia, you see, you have to run 8 lines from Jamaica to Australia. It's going to cost a lot. What we are going to do, if you have 8 lines in Jamaica, we are going to send only 1 line from Jamaica to Australia. And when you get to Australia, we convert that 1 line back to 8 lines. So when we have 8 here, we go to Australia, we have 8. That process is called multiplexing. So in this case, we cannot use multiplexing here because multiplexing is best when we are having distant transmission. And then we talk about spreading. Spreading is a means where we use a wider bandwidth so that we can protect the data. For example, if I'm sending a letter to you, the letter I'm writing must be smaller than the envelope. Envelope covers the letter. And why envelope is covering the letter? To protect it so that it does not go to the wrong hand. That's why I talk about spreading. But our main research is going to the latest technology using ACDCP, Automatic Congestion Detection and Control Protocol. We have been doing this in the lab to have a configured protocol that can be able to stop congestion. Next. Okay, see the network diagram. If you see here, sorry, I have to move. If you look at here, we have a number of nodes sending to a switch. We have a number of nodes, each node like a computer sending to a switch. And we have a number of nodes, PC sending to a switch. The work of switch is an activity that has to send to a router. And all this are going to one router. These are sending to router, all this sending to router. There's chances that this router cannot be able to contain what is happening. Then this router, we need to have ACDP or a protocol. This protocol will be able to assist this particular router. If there is any congestion, then this will assist so that some of the packets will go through here and go to the destination. Some of the packets will go through here and go to the destination. This is what the work we're doing now. If we can be able to establish ACDCP, that's Automatic Congestion Detection and Control Protocol, then we have achieved M of this work, and we're working that in the university library. Next. Now, in conclusion, wireless sensor network can effectively act to monitor, detect, and prevent consequences of natural disaster, so like I said earlier, such as floods, earthquake, hurricane, tornadoes, tsunamis. It has also low energy consumption. Anything we have to say, why do you want to go to sensor technology? Because very, very low energy. These days, nobody wants to spend more on electricity. So if what we are using is high electricity, then people have started removing normal bulb to LEDs, getting smart TVs. Why? You are trying to minimize the cost of energy. The cost of energy. It has low energy consumption and progressive signal. Those signals can be combined to low frequency channel, from a low frequency channel to a higher bandwidth channel by the process of multiplexing. This multiplexing is also important during long distance transmission. Multiplexing process can be used to achieve better system performance due to improved efficiency, while privacy, security of signal, data, and anti-jamming can also be achieved by spreading techniques. Okay, let me go down to the simulation part and see if the system can work. So this simulation is done on packet tracer. Packet tracer is Cisco technology that needs higher memory. And this computer, this laptop has very small memory to be able to read it. That's one of the problems we're having testing this before coming here. So it's unfortunate. I don't know it's not opening.
While you test, one question.
Okay, can ask question.
Yes, the question is in relation to implications for training. We have all this technology and looking towards simulation and looking towards sensory mechanisms and so on. What does this have for implication for training? What can we do to ensure that we get up to speed in relation to this in the Caribbean?
Yes. No, come again with the question. Let me get the question.
Okay, we have training agencies, but I don't think they focus on sensors training and smart technology. Smart city is something just in the mind, in my view. And I'm just wondering how we leapfrog, as Dr. Grace mentioned, Dr. McKee mentioned, leapfrog into this technology of having a smart city, a smart home. You know, I just don't know how does this help us in training?
Well,
what can we do in training?
If we first, like when we had under the Jamaica Institution of Engineers, when we met the Prime Minister, he's talking about project that is very feasible. Then if we look at these projects and see funded, it is in other countries, and if we bring it down here, what we're going to do is to train persons on it. Some agencies are focusing where you will fund. If you have a company and you want to be a trainer in this area, and the amount what it will cost you, and the company is already implemented, you will not go into that area. But if we have somebody who is more committed and is willing to fund it, though the starting will be expensive, but at long run we are going to see the benefit of it. If we have smart city, if we have smart homes, you know what it might cost us to set up a smart home. But you stay anywhere you are and know what is happening in your house. You can even know whether your babysitter is taking care of your son or your daughter very well. It might be costly. These are the things. Then if you are driving from your house, you are going to Newcastle, and there's traffic. Other places they have it. What happened? You see your radio telling you don't use this store because of traffic. You see the board telling you what is happening. This we set a lot of gas going on the queue. So, but for the training agency, it's left for the country to go into the implementation. What we have to do as institution is to research in this area. Then it's left for them to implement.
That's really backing down basically the funding and providing training to
Isn't it also the willingness of industry to put in the investment and to shift the way, you know, they do business? You're talking about smart homes. What is that something that our construction industry is willing to take on to build these smart homes or whatever? I don't know. Or it is that the users are in that mindset about, you know, to shift from the traditional thing about what a home is that
we're not forward thinking. So in another decade we'll still be in the same position. If you want to put in a smart system where you watch out on all the walls and put in all the conduits and all the
yes. So
it's for the future.
Yeah, so we're not really, and sometimes the investment, the money is not here.
So it's what we want to
a factor back to the cost.
Yeah, just piggybacking on what the comment in terms of coming into that new technology, it's gonna be an overhaul. Yeah, because it's we've been operating in a certain I would say infrastructural overhaul, because we have been using certain technology or certain and looking at this is the new thing. And so you mentioned about construction, gentlemen. You talk about the construction industry. They have to be willing to adapt. I mean, and I'll give an example. I see a problem, especially here in the Caribbean, especially where I come from, in St. Kitts and Nevis. We have these new cars out. And then
hybrid cars?
Not a hybrid car, these new cars as in with computer technology, power windows, all of those things.
Right.
Hybrids.
Well, okay, hybrid. I didn't realize what
Battery.
hybrid.
Battery and gas.
Well, speaking specifically to the computer, like power windows and all of those things. And when something goes wrong, we don't have the mechanics. The mechanics are not trained
To fix
them because they have not upgraded them. They're not. They only know how. They only know the basic.
But it's not necessary that they don't upgrade. It is also a factor of the training system.
Yes.
The training system, yes.
So the tool itself to get people to upskill, right? Because one has to, you see, there's got to be the link wherein training institution or the training sector has to see themselves as integral to the industry, that they become the, I see that they become the manufacturing that produce the people to working in the industry. And so they should be taking cues or discussing what are the changes coming up and how we should be changing our approach to produce the people. We think it is easier and most cost effective to train the same old way because it doesn't impact upon the budget and sometimes government.
So you have to unlearn.
Government is not also
and retool and retrain.
Government is providing the funding to these institutions. It's not in sync. Yes, we talk about change, or we need to meet what industry want, but who's going to pay for it? This is the bottom line.
That's why I say that it has to be a combination of private and public
But
to pay for it.
What we need to be really good, and the way we need to be really good, I call it the partnership should be some kind of institutional relationship the school should establish with industry. They say, okay, we are doing this, we don't have the investments to buy these new parts of it, but you could allow us, students, to come in, see whatever, or you're part of your workforce come in and can help in the instructional process and teach and whatever. We sometimes have to relax the requirements about the teaching process and integrity that you have to be trained. It's transfer of knowledge. Or learning.
Yeah, but some people also don't, they're not receptive to new things. Right? Because right now in Trinidad, the new thing now in Trinidad is these hybrid vehicles, right? Which is a combination of gas and battery, right? And it's only a handful of people that could really fix these vehicles, right? And mechanics on the whole, they're not even self-receptive to the hybrid vehicle, because when you go on and ask, what do you think about the hybrid vehicles? Do you think I should get one? And they're like, no, it gives a lot of trouble. And it's because they're not even open. They don't know how to fix it, and they're not even open to learn how to do it. Right? So
like I was trying, it ran initially and now it's hanging because I need more memory. Like the professor was asking of training. If you see these days we are talking about 5G. 5G means fifth generation network. I'm not talking about 5G Sonic for big countries, for fifth generation network. But in Jamaica, some companies are advertising 4G IoT, but we don't have full 4G. What we have is about 3.5G. So if technology is moving, we wanted to keep 5G Sonic in Jamaica, get counterpart from US and Australia to come here, but the platform they have does not support 5G. So if we're moving with this technology, cost of phone will be cheap. I visited my friend in Canada and said, take my phone if you want to call anybody in Canada, US, Europe, you can call. But don't call Africa or even Jamaica, because it's going to be more expensive. Because of this network system. If we have good network system, it will help us in controlling this kind. This item, and this means training. If we are not there, we cannot be able to solve this system problem. This is where they come, they attack us, and they get away with it. How many of us here have the houses where we are living registered? Yes, if you live in US, you don't listen where you're living. It's a crime. If you the house where you're living will be on the system. So that if I ask you your name, your ID you don't have, I ask you your name and you give us your date of birth, they can call it and be able to know where you're living. So if you know where you're living, they can be able to control crime. And we have not only in this, many other companies, just what they call American process of deciding where you're living. If you pack out from one house to another, you have 2 weeks to make sure you're inside the new place. So these things, we are not doing those things, and this network, this new network is support them and to help us to control crime. You can hit me here and run to Montego, go to the next hotel in Montego and be enjoying yourself. So we're trying our best,
What about the confidentiality in this sensor?
Huh?
The confidentiality and the legality of using these sensors?
Okay. Under ICT, the government legislation for those like when we are going to cloud or this about cloud. We have in the cloud computing we have secondary, we have primary cloud and public cloud. But at hybrid, we don't have any control. At hybrid means very high frequency, no control. But for public and private cloud, like your email.
Because I'm saying these things can be breached, and if it falls into the wrong hands, then that could be it could be catastrophic for persons involved with the information.
Government agencies have their own ICT laws, which is where if you're doing anything scamming, you can be tracked. If you look at here, like this question, these are IP. These are all the machines here have their IP addresses. Every machine has an IP, and that's what we use to track. If you're using your phone and doing that, what we're using to track. So by the time we have those sensors, each sensor will have an IP. That's why they have all their IPs, and we use that to know which particular sensor is sending data. And in the same way, we can by government policy. The government policy, because they are the one that will be implementing it for the city. We are not using it to do any other than to monitor crimes. But where the law like I'm talking is like if you go to big supermarkets where you can remove your clothes and change a new one and test. They don't put these things inside there. Because if you go to bedroom and there's a sensor that monitoring you can sue this hotel.
Exactly, that's why I asked for confidentiality.
But if you come to this hotel and you go to bedroom, you remove your clothes and you are using bedroom, and next day you see yourself naked on the bed, you can see the hotel. But those
it has limits.
They have limits in those areas. Even in the public places, they don't put these cameras in the toilet.
Yes.
They don't put it in the toilet. Instead, they will do like RFID on the clothes. They put RFID, radio frequency identification on the material, so that if you are living, if you put it on and you are living, it will be detected. So these are new technologies to protect control, not putting camera inside the bedroom. But outside, there's government regulation. Even drones too have regulation, because I cannot fly my drone over your own house without permission.
Yes,
if I have my
it's illegal in Trinidad.
Or another country, I will be able to track what they are doing. Because every drone has cameras and monitoring.
Okay. It sounds like a good
conversation that if we all understand the benefits, because yes, there are conflicts, there are privacy issues and concerns, but in terms of even the crime rate in our countries and even the schools, to control what is happening in the schools, if we are able to utilize these technological devices and advancements, then I'm sure we'll be better able, to put on things. As you said, you're able to stay elsewhere and see what is happening at home. You're able to stay elsewhere, see what is happening in the classroom. Because once the teacher is out of the classroom, the many things that are happening inside there, we're able to see, then we'll be better able to prevent or to manage.
Yes.
So it's just for us to promote the benefits and to put the legal infrastructure in place to to cover us and to protect our rights as citizens too.
So in addition to what she's saying now, like being outside and see what is happening in your house, it is not only if we, unfortunately, we don't have the whole black funnels, F-U-R-N-S-E. Funnels is where they manufacture all this iron, grease, iron metals they use in building houses. Nobody enters inside the funnels. Nobody, because if you enter the funnels, you just melt like ice water. But billets and raw material like this kind of billet, it enters inside the funnels and it heated to red hot. And when it reaches the temperature, it will come out to the size of the type of rod. How you see persons in the office in AC monitoring what is happening inside the funnels. So nobody would go there. So this sensor technology will help us send the material inside. When you heat it to the red hot, to the highest temperature, then another system will push it out. Because you'll be looking at what is happening inside there. So it happens in other countries. If you go to the airport, policeman will stay in the office watching what is happening. And even when they are announcing, don't make sure you don't leave your bag unattended. They'll be monitoring what is happening, monitoring the movement. Then some will use dog to smell this. But once anything happens, you see many persons. From when I was studying in Germany, as a student, I put my money on the machine to get the juice. I put my money, the juice does not come. I have to use my leg, box the machine to get the immediately I did that, the next thing, policeman, was Mackenzie, what are you doing here? Because I spoke that since I put my money, I'm not doing my drink. He saw me that I put my money. He said, colleague, you're fair. I said, go away from me. I didn't have to leave the place. I lost my money. How did he see me? Because he had already seen me in the camera. I was also doing my same work, doing my same packing things on Windows. When I stood up like this for about 2-3 minutes, the check comes and said, I will not pay you 12 Dutch mark. Then it was Dutch mark. Oh, I'm going to pay you 6 Dutch mark. Why? Because you need a machine time. I'm not working at the speed of the machine. So then, wow, because all things in place to monitor you. So the boss must not be looking at you for you to work. Wherever he is, he's monitoring you. So this thing help them. So if we have this in place here, I know that we cannot achieve it in one day. But if we get like
but we should have a pilot
the fact that we have CCTV we have smart city in New Kingston. If anybody is going to New Kingston, they'll tell you if you are robbery, don't try that place because they have everything to arrest you. That one alone will make robbery to stop you. If we have it all over, it will stop. Nobody will just go and then use knives and kill their own. I don't know if it's okay for her.
Well, I am not, honestly, I am not yet convinced with the crime situation and using the sensors yet, but I will fully endorse it as part of the environmental in detecting earthquakes and tsunamis and hurricanes and these things. Definitely it would be useful as a tool to warn, a warning tool, because I mean you can't stop it. It's a natural disaster. But
we have to be truthful. We can
warning so that you can prepare people
prepare for it, but we cannot. Nobody can stop anything that's natural.
Yeah.
We can only alert us. You buy your clothes, and if you see, because we can't stop it. If you see, 90% of Jamaican houses are built with hurricane proof.
Yeah, but I'm sorry, but I'm just not convinced yet with the crime fighting situation.
That can take a lot more.
Yeah, because these are criminals. They I know could get the same equipment that the police have. They could source it too. You know, so
smart criminals.
Yeah. You know, but probably a pilot study. You can run it and see how well it works. You know, a small section you could pilot and see if it's feasible, if it would work, and then probably you could expand it to the city or that sort of thing.
Okay.
Yeah.
Thank you.
Thanks.
Thank you. Thank you.
Thank you everybody for coming,
Thank you.
and hope to see you tomorrow. Please the Lord.
All right.
All right.
Okay.